Hey, OChemisters, this is Mrs. Vanderwille bringing you Chapter 7, Part 2, or Section 2, Part 2 of your alcohol notes. Okay, so we left off learning how to name certain alcohols, all right? And so we're going to continue on. We're going to classify them, and then we're going to talk about phenols a little bit later on. So the classification of alcohols are either primary, secondary, or tertiary. Depends on how many carbons are attached to the carbon that's bonded to the OH, all right? So methanol is considered primary as well. Methanol, if you consider it, has no carbons attached to it. So a primary over here has one carbon. There's your carbon group. It's two hydrogens on it. So what do you think secondary is? Take a wild stab. Has, whoops, come here, two carbons attached to it right here. Right here's one and here's the other one. So remember, you're always focused on the carbon that has the OH group on it. Now tertiary, it should look even more familiar. We have 1, 2, 3 carbons attached to the carbon with the OH, okay? So why do you think that this is important? Well, let me ask you this. Does the idea of having a primary, secondary, or tertiary carbon sound familiar? Your answer should be a resounding yes, ma'am. It is foreshadowing of things to come. We're talking about the SN1, SN2, E1, E2 type reactions, okay? So that's why it's important, and it's going to show up a little bit later on in this unit. But for right now, let's go back and classify the chart in section 0.1 as primary, secondary, tertiary. So why don't we go back to those pages and fill that part in. So welcome back. And so what do you think the methanol is going to be? A primary, secondary, or tertiary? Why don't you write in your answer? The same thing with ethanol, propanol, and 2-propanol. So pause this, fill out the chart, and then come back. Okay, so the first three are considered primary. Why? Because how many carbons are attached here? That's none. So we said, remember, we'll consider it to be primary. This carbon has only one carbon attached to it, and this carbon has only one carbon attached to it. So what about this one? See this carbon right here? How many carbons are attached to it? 1, 2. Therefore, it is secondary. How about the next page? Why don't you go ahead and fill that chart out? Welcome back, and hopefully you figure this out. So if it's off the first carbon, you only have one other carbon attached to the first one, so it's primary. And the 2-butanol, here's the carbon we're looking at. There's 1, 2 carbons, it's secondary. In our isobutyl, or our 2-methyl 1-propanol, here's the carbon we're looking at. It only has one carbon attached to it. So again, it's primary. And so over here, this carbon has 1, 2, 3, so it is tertiary. Hopefully that isn't too big of a problem for you guys. And let's go back to our notes where we left off, okay? Okay, at the start of the first video, I showed you like water, a regular alcohol, and a phenol. And so again, the phenol has that benzene ring with an OH attached. It's one of your big 9, if you remember that. So how would I name number 1? Plain old phenol. This is a review from our aromatic chapter, by the way. And over here, how would I name this one? So what about the next one? So it's just p-chlorophenol there. So it's a cross, so it's your p-chloro. And then what about this one? It's your 2,4,6-tribromophenol. So your phenol takes the priority. You don't need to number it. Again, that's a review from chapter 4. Okay. So then it says, this is really important. So if you can, go ahead and like say star this. Here, let's put a couple stars here. This is an important section here. It says the hydroxyl group is named as a substituent when it occurs in the same molecule with these 3 right here. So let's kind of highlight these 3. We have either, whoops, I was trying to get the highlighter here, carboxylic acids, aldehydes, or ketone functional groups, okay? Those take priority over the alcohols. Did you catch that? I'll say it again. These 3 functional groups take priority over alcohols, okay? So I wrote here, know your functional groups, okay? While you're at it, know your big 9. You might need to go back and review some of this stuff to be truly successful in these later sections, okay? So know your functional group. So now we're going to go down here and let's name these. So what do you notice right here, okay? All right, just fixed this. I think it got shifted somehow, I'm not really sure. But if you ever see a C double bond or COOH, remember what we said earlier on. That's the same thing as saying C double bond O, OH. Do you remember at the very beginning of the year when we're doing the Lewis dot diagrams? We refer to that as always writing it out this way. So now what? Do you recognize this as a carboxylic acid? And the answer is yes. So is that one of the highlighted things? Yes. The carboxylic acid takes priority. And so do you remember how to name, let's see here, let me get this out here. Don't want a pen, here we go, or a highlighter, there we go. Do you recognize this as one of the big 9? All right, and you should, that's your benzoic acid. So if that's your benzoic acid, then the OH is just a substituent, as a side chain. So you would need to write this as a hydroxy. So it's an M, which means meta, hydroxy benzoic acid. So when your OH is a side chain, it's a hydroxy. If you have a big 9 that's a carboxylic acid, an aldehyde, or a ketone, it takes the priority. So I'm over here. Do you recognize what a CHO is? So if you ever see something written as a CHO, like this, all right, it's what this is right here. It's a C double bond OH. And what's that functional group? Do you remember what that is? You should. It's one of the ones you had to memorize, one of the 13. It is an aldehyde, all right? So it's your aldehyde, which is a starred one. So that once again takes priority in the naming. So what do you recognize here? That this is one of your big 9. Do you remember what that was called? Maybe, maybe not. It's called benzaldehyde. So now what? The hydroxy is the substituent. It's the side chain. It's not the priority. So it's p-hydroxy benzaldehyde. Could you also write this as a 4-hydroxy benzaldehyde? Of course you can. Okay. So what about this? This is a nitro group. Is nitrobenzene a big 9? No, it is not. So now what takes the priority? It is not the nitro, it's the hydroxide. So then this is your big 9. And what do we call that? That is your phenol. So I have ortho or O-nitrophenol, okay? Because it's in the ortho. Could you also put 2-nitrophenol? Sure you can, all right? And then, of course, I did write, no, this is not orthohydroxynitrobenzene, because nitrobenzene is not a big 9, okay? Hopefully that helps you, okay? So that's naming some phenols. All right, so problem number 1, write the structure for p-ethyl phenol. All right, so what takes the priority? The OH does. Ethylbenzene is not a carboxylic acid, an acetone, or a ketone. All right, so how would I do that? Well, make your phenol first. There we go. And now we're going to put the ethyl group. Well, straight across from it, there is your p-ethyl phenol. Well, your pentachlorophenol, go ahead and just draw that out right now. Okay, how'd you do? Well, this is what I came up with. So why are no numbers needed? Do you remember when you have a benzene ring, each carbon only gets one thing coming off of it, because this is like 1.5 bonds. You remember that? So it gets one carbon, and one other thing. So there can't be a hydroxide, no, sorry, I said it wrong, the alcohol or a chlorine off of the same carbon. So because you have 5 chlorines and you have 1 OH group because of the phenol, then that's all you're left with, okay? So what about number 3? So notice that the hydroxy is listed as a substituent. So what is my main chain is the acetophenone. What's an O-N-E? That's your ketone, all right? So your acetophenone is actually this, okay? But Mrs. Vanderlei, I don't know what this acetyl thingy is, all right? Well, do you remember when we had acetate as a polyatomic ion? What was its formula? CH3COOH. You had 2 carbons in there, is there? C2H3O2. Remember that as an acetate? So the old way of saying 2 carbons was actually the ACET kind of thing, like acetic acid, your acetate. So if you have acetophenone, you have 2 carbons, and then off of here is your ketone. Do you see that? So, and then your phenone tells you it's like part of the phenol issue here, okay? So that would be your acetophenone, and now I have an orthohydroxy. Oops. So that may have been probably a little bit trickier, and that's why I gave it to you, okay? So what I'd like you to do now is turn to the back of your packet, and you will see this worksheet. Let me pull it up. And here it is, okay? So this is your homework to do after the naming. You have plenty of time to do it if you don't waste your time, okay? This is not social hour. This is, hey, let's get our homework done so I don't have to worry about it over a 3-day weekend time, okay? So I'll just say, don't wait to be great. Take care, and we'll see you next time. Bye-bye.